Hi, everyone. Thanks for joining us today for Intro to Bazel using macOS. I'm here with John Cabaniss, DevOps Coach here at MacStadium. Just as a reminder, you will be muted for this duration of the webinar. If you have any questions for John, please put them in the chat or the questions pane, and we will get to them at the end of the webinar. We'll do our best to answer all questions, but if we run out of time, we will get back to you after the webinar. Now, without further ado, I'm going to hand things over to John.
Thanks, Stephanie. And hello, everyone. So this is a basics talk. There's two goals, two target audiences. First, maybe you're a macOS developer and your company uses Bazel, or you want to look and evaluate what it would take to move to a Bazel solution, and you want to know some of the fundamental how to get started pieces. The other thing, target audience, is if your company uses Bazel actively, and you're on the Linux or Windows side of the house, and you want to know how to bring the macOS people into the fold, what are the key issues, what's the nuances you're going to find dealing with macOS or Xcode. MacStadium, by the way, is the largest cloud provider of infrastructure as a service for Apple-based products. Right in this picture, you've got the 2013 Mac Pros on the left, and then a bunch of our networking, switches, storage, and all that on the right. We've got over 20,000 nodes, which means mainly Mac Pros and Mac Minis. And there's actually not enough supply right now on the market for anyone else to come close to catching us. And that's because we've been at this for quite a bit of time. Most everyone has kind of heard of us. If you do Mac OS dev team, our target audience is really larger teams. Once you're past the point of being able to run on a couple Mac Minis, that's when you really reach out for a more sophisticated CI/CD cloud-based solution. So what's the basic agenda? Well, we got some implementation goals. Ultimately, everyone's got to have a goal if you're going to adopt new technology. There's two bits of core concept, and then we're going to take a quick look at Xcode and Bazel integration specifics. And then we're going to talk about workflows. Workflows are important because if you're here, you are serious about doing builds at real speed with enterprise level scaling ability. And then I'm going to have a summary slide at the end, gotchas, decisions, and best practices just to keep up. We got bit.ly links spread throughout. We referenced heavily the 2019 BazelCon, which actually had iOS as a focus. So a lot of the talks there talk specifically about Xcode and iOS, and they're great talks. I'd highly encourage you to check them out, especially if you've got a topic that's going to be technically addressed here. And all of this information is going to be repackaged as a blog post. All the links and all the headline technical topics associated with those links, so that you're going to have a reference material afterwards. So what's the goal of Bazel? Real simple, 90% off. That's pretty much the only thing anyone wants to talk about. That's not my number, and that's not Google's number. That's reported by a lot of enterprise groups, BMW being one of them, and that's the headline talk they gave at this last year's BazelCon. They actually tried all three approaches I'm going to high level discuss here. So when you say shared cache, that's not, a lot of people who are hardcore Bazel don't really consider that to be real Bazel. It's Bazel, you use Bazel, you're using a network-based cache, and it's easy. You're also not going to get the benefits. Remote execution is what everyone wants to talk about, with good reason. That's where you're really seeing that 90% figure. And remote execution is going to spread your build across multiple machines in real time and then reassemble it. Less talked about, but just as important, is remote caching. That's really, we mean remote RAM caching. And obviously, if you can do all your caching in RAM, it's going to be faster. BMW did try all three of these. They don't talk about it, but they actually did share cache as their first step. I know the consultants who helped implement that, and that was the first couple adopters just did a real simple setup. And again, it's easy. There's a clear path if you're just using a simple networked storage shared space. Mac Mini, you got three basic approaches here that I'm going to reference throughout the talk. You can do bare metal, which is that top one, and that in the shared cache world looks like a network drive. VMware is a virtualization technology that works with Mac OS, has for a long time, and they've got a clone series, instant link clones. And then Orca, which is the orchestration of Kubernetes with Apple by MacStadium, we have attached disk, which is again shared storage. You can pass it around from VM to VM. Remote execution is where it's at. It's the most difficult, also the most beneficial. Oftentimes you're going to have an expert team try and help maintain this. You're going to have some gotchas. The biggest one is reassembling the code. You spread your code, your build throughout a bunch of machines. Now you need to put it back together in a consistent fashion that is representative. Google did a talk about this at the BazelCon. That's them on the top link. It's also a tough problem. There is a new startup, EngFlow. They're doing a managed remote execution service that's worth checking out. They do not have iOS, macOS support at this second, but they do have that on the roadmap, and they have done some proof of concepts. So they're pretty far down the field, actually. Remote caching, remote RAM-based caching is beneficial. It's much easier than remote execution. You're not going to get quite as much benefit. There's a couple non-Bazel projects that I've referenced here as examples of working remote caching. It's a good add-on. It is in addition to remote execution. You can do both remote execution and remote caching at the same time. So if you've got remote execution working and you really want to get your maximum value, remote caching is a logical place to go. And for the adoption curve, some people would argue you should do remote caching first because it's easier than remote execution. And that's a business decision that each company needs to make for themselves. Core concepts. Let's talk about the things you're going to have to be aware of. Tool chains and wrappers, and then we're going to get more into Xcode specifics. And a lot of people who aren't macOS developers don't really know what we mean by tool chain. So if you're getting started with Bazel, go check out a bootcamp. This reference here is from this last year's BazelCon. Every BazelCon obviously has a Bazel bootcamp. Also, every WWDC, the big annual release by Apple, the last couple of years has had a Bazel work bootcamp as well. And there's a couple other ones, and they're all about the same. They're all good. In this case, I grabbed the dependency list, and this is a pretty reasonable set of dependencies to install for a Bazel build. It's not over the top, it's not the minimum set, but it's a good in between. And so I'd say this bootcamp did a pretty good job of highlighting the packages you might have to deal with and putting that in a good packaged experience for a dev to walk through on their own. This is a toolchain error. This happened on one of our benchmarking machines. It took us a while to track down. As you can see, this is a Python error. And at the top, you got PyNV and Python 3.8.0 already installed. Then can't find pip. And then the first thing I do is a Python -- version, and it comes with the wrong version. This is typical. Now, this could be a lot of things. This could be a bad Python environment variable for the profile. This could just be a dependency pointer, but it's not. It actually is Apple Toolchain. 2.7.16 was installed on this VM first, and the Apple Toolchain grabbed onto it, didn't want to let go. This is very typical. If you have any dependency type errors while on a macOS using Bazel, the first thing you should do is a version or a V or a -- version or whatever the syntax is. There's a couple ways of fixing it. Local devs you can fix it inside of a terminal as a one-off, run your build and try and fix it for your full profile if you're working on like a laptop or something like that. Old school is virtual machines. You pretty much only have one version ever installed in an image. That works real well if you're working with VMware or Orca. You can have a base image, and maybe you use Chef or Ansible to help install packages, and then you just build it from scratch whenever you've got a new release out. Then you've only ever had one version, and that works well. Looking forward, there are significant improvements in the works. Apple is aware. You got 2 different teams on this. macOS itself, that team is providing toolchain improvements, trying to make your lives easier, trying to make this less of a thing. Xcode separately is trying to implement a regression system, so you can specify older versions of Xcode with a newer version loaded. And both those are works in progress, but both of them are getting active attention. Ultimately, Apple wants your experience in macOS to be seamless and wants devs to be able to call any package they would like. We're just not quite there yet. Wrappers are a core concept in Bazel. Typically, they're .shell scripts. the idea is you have a shell script call your build, and at first it doesn't call Bazel at all. It calls whatever you were using. And then as you move towards adoption, the shell scripts, which are ideally checked in and part of a repo, just get checked out and does just call the same shell scripts. So the dev code doesn't really change, and behind the scenes, you're changing the build engine. And that's been a pretty broadly accepted method of adoption for Bazel and best practices for Bazel. Again, from our internal benchmarking machines, we've got a run Wikipedia build here, which does not call Bazel currently. It does call Python, which launches Xcode directly. This is, like I said, a really common thing to do. And then your adoption curve is lower. This, along with a bunch of other things, is mentioned by Etsy in their talk at BazelCon. They did a great overview of early adoption and what it took to really move towards Bazel. And the effort's non-trivial. You really want to give consideration to your devs and your workflows. On that vein, you want to check in everything you can, configs especially. So Bazel has a lot of great features and a lot of extra features every release. It's also really good at backwards compatibility. It is the case that you can upgrade your Bazel system to fix a bug and not adopt new changes. When you decide you want to do new features or new changes, having a managed Bazel RC file that you check out is a great idea. This lets you organizationally say, hey, we're going to adopt this new feature that we want for various reasons. It's going to break stuff. Everyone then knows this sprint's going to have break Bazel days and then fix Bazel days. And everyone knows under the new fork, you've got this feature. It allows for organized breaking and adoption of the features you want. You also have a lot of various flags. Bazel RC has quite a variety of ways to handle every program, and you really want to have an organizational decision on how this is going to work moving forward. And that's for a lot of reasons. That's for cross-team troubleshooting, that's for collaboration. Not only that, it's to make sure that your app launches in the most stable way possible. So there's some decisions that you just want to make at a very high level, and you want input from all the team members before you make those changes, obviously. Which brings us to a little bit of Xcode and Bazel integration. In general, these are the two big items that you need to make a decision on. Not exactly day one, but you'll need to make calls around these two topics. Rules are the biggest one. There's no easy answer here. Default rules for each packages are always supported by the open source community, but they're usually not built for Xcode. So there's almost always an issue or two. Custom rules work better. It's a lot of maintenance. It's every release for every package. You got to make sure you go and you modify the rules. This leads to more labor than most people would think at first. The Bazel Federation is trying to organize this at a high level and a really high quality level of support and get mass community adoption and try and solve things like, hey, this doesn't work for Xcode. That's a work in progress. They're making a lot of progress, and I think they're going to be featured at every BazelCon moving forward. In the meantime, you got to, as an organization, decide if you want to do defaults, custom rules, or a combination, and when it makes sense for you to take packages under your own wing and say, all right, we can't live with these rules, so we have to do something else. For the Bazel Xcode integration, you got two open source projects as examples, Tulsi and XChammer. Now, obviously, Tulsi's by Google, and then XChammer pretty much came next by Pinterest. And there's reasons why Pinterest went their own way and decided to make their own integration, and then they open sourced it because they're being nice and good citizens. These give you two good examples of things to try from day one. If you're in the adoption cycle or you're early on, you want to evaluate the pros and the cons, because even though fundamentally at a high level they do the same functionality, the implementation is very different. Learn what works best for your build, what doesn't, really test out both these two for a little bit. Decide if you want to use either one of them or if you want to roll your own. All three are valid options. When you implement Xcode, everyone wants to use external build system targets. That's not what you want to use for Bazel. People theorize whether it's a legacy target or what its actual function is, but ultimately it doesn't work well. What does work well is run script phase. It's a phase inside of every target. And you remember the shell scripts we just talked about, which are a best practice for Bazel anyway? They're really needed for Xcode. And you can get as fancy as you want with this stuff. You've got a whole bunch of advanced scripting options. You can do targeted scripts. People who've done configuration management for a long time are going to argue that .shell scripts are not exactly a best practice anymore. And if you're running enterprise prod, Puppet, Chef, Ansible, okay, they have a point. But for dev work and for build pipelines and for using Bazel, shell scripts work just fine. You do need to make sure they're all checked in. You want a peer review. You want a version control. You want to do all the normal things you do with code, but ultimately you're using this code to help facilitate your build process. The other thing you got to do is copy some artifacts, and you can try and do symbolic links if you want. The artifacts produced by Bazel are not quite in the same spot Xcode wants them to be. Xcode doesn't really care as long as they end up existing on the path it's expecting, so it'll work just fine with something moved. Lyft covers this along with a bunch of other adoption topics in their talk. Now, the one thing about using symbolic links to copy artifacts instead of actual copying artifacts, yeah, it's faster, but it creates problems. And we'll get into that in just 1 second. The next big decision you're going to have to make is headers versus frameworks. Everyone wants to start using headers. Frameworks are Xcode native. There's a lot of tutorials on frameworks. I would highly encourage you, if you're not familiar, to go get familiar. That's really where you want to be, ultimately. Headers are just an import. They're a single line. They can call part of a framework. That works just fine for MVPs, POCs, really simple apps. Eventually, pulling in your imports in a header is going to collapse. And I can't tell you exactly when or the level of complexity that it will collapse at, but I can tell you how it's going to collapse, and it's going to collapse in one of 2 ways. LinkedIn talks about this extensively, by the way. If you really want to know all the problems you're going to hit with headers and the solutions from frameworks and the problems of frameworks, they do an hour-long talk on it. The 2 problems you're going to have are dependencies and paths. So dependencies, there's a lot of them. That example I showed earlier had 14 dependencies, and that's a boot camp example. That's not a real app. Google gave a really good talk, wanted not to have Bazel dependencies, and ultimately their suggestion was to minimize them. In the example they used, they grabbed a Go SDK, and instead of downloading the full thing at 120 megs, they were able to trim it down to 5 meg download. That's a lot simpler. It also has a lot less moving parts. It's also a lot more reliable. And that's one of the other things. If you have a dependency that's less stable than your app, you now have the stability of your least stable dependency in general. So ultimately, you want to take a look at dependencies, whether you need them, what you can trim down, what you need to keep. Paths are the other thing, and paths are just going to be a real problem. Symbolic links will collapse on this, so will regular dependencies, so will bad mappings. Outside of checking the version, and that's really a macOS thing, this is going to be your most problematic and consistent issue. You've got a lot of simple solutions which involve just tweaking your header and frameworks. When that stops working and you really got to get a good search algorithm, a really detailed way to find all your non-relative paths and absolute paths and the relative paths and symbolic links, there's a bunch of approaches. Dropbox gave an excellent talk. It's really dense. What I would do is go to this talk with some technical context. Look at a problem when you're trying to do a Bazel implementation. Think about a solution that you want to do. Then go reference this talk. It's probably covered. And this guy can probably tell you the pros and the cons. And he does a really good job of that. And then you got to decide what's best for you. Not every mapping solution, not every querying solution, not every path lookup solution is going to work for every app. And sometimes you get apps that with the organization, a default organization structure that just works better for some reason. That's going to be on you to decide for yourself with your individual build. But this is going to be a great starting point for you and a lot of work that's you don't have to recreate. Workflows. Again, if you're here, you're serious about macOS CI/CD, you're serious about a build pipeline, that means you have an existing infrastructure that you need to consider when taking Bazel under your wing. For business reasons, almost all serious levels of macOS are going to be fixed expenses. If you're with MacStadium, we do a monthly lease. If you're on your own, you probably have sunk equipment at cost at this point. You're probably beyond the point where you have just a couple Mac minis and it's not that big a deal. And as you spend more and more money on Mac infrastructure, you want to use it better. And that's the level of sophistication of your pipeline is directly proportionate to your spend. The more money you spend, the more people care that you're using it and you're getting the value of every dollar you spend. And there's two technical answers to ensuring that you get high usage out of your sunk costs. Hot standby, and then supporting multiple build types. Hot standby is in use by every CI/CD customer MacStadium has, and most of the major accounts that aren't CI/CD customers. And it's a pretty simple concept. Your goal is to service a customer in about 5 seconds from request, or pull, or PR, or merge, or whatever. And to do that, you do a cleanup or a system restore ahead of time. Very simple concept. Bare metals usually do a data delete, and then if you have to do a system restore, that's an out of commission kind of a thing. You try and do that in a maintenance cycle or something. If you're trying on VMware, you usually do a snapshot revert. That's the most stable way to do that, and it's about a 5-minute lead time. And if you're on the Kubernetes-based Orca, you're going to do a delete and deploy. And all these have equivalent functionality. And then you have the system waiting, because again, this is now suck cost. You may as well have everything, all your equipment ready to use all the time. And that's the logic. Then there's multiple builds. The other way to get the most value out of your dollar for macOS is to reduce spend in other places. It turns out that C-Lang C++ libraries are great. They work really well in macOS. So you can have your CI/CD master, whether it's Jenkins or TeamCity or GitLab or BuildKite or whatever, point when there's resources available and just do C++ builds on macOS. Android's even easier. There's even less adoption libraries. It just builds better. Those are the two most common non-macOS builds, which clearly if you're here, macOS and iOS builds all must be, they must be done on Apple hardware. This lets these other two builds, as there's available capacity, build on macOS and reduce cloud spending other places. This helps you reduce your net cloud budget while still getting the maximum value. And really, a lot of companies have gone to this adoption. This brings up a lot of questions. So, do you have one image that can support all 3 build types? Is that possible for your company? Is the image too big? If you have to split up the images, obviously this now becomes in conflict with the hot standby model. Note that if you can actually make all 3 of these builds work on one image, great, hot standby and multiple builds work at the same time. If you need to break them up, you got to make a decision about how you're going to break them up. Also, virtualization lets you support multiple operating systems. A lot of people will do a 90% hot standby and 10% whatever, and let you pick an OS, pick a different version. And again, Apple Toolchain is an issue, so you might have a Java version 7 somewhere, something like that, that you can call on demand. And then there's other companies that really can't do this stuff on the same image. So now you got 2 image types. And you might do something like a 60% Mac OS, 30% C++ hot standby until your Mac OS infrastructure gets filled up, and then you start taking out the C builds. What does that mean for Bazel? Well, same question applies fundamentally. Can you use one image, which is going to take the Bazel input, and is going to do remote execution, in which case your entire inventory can be hot standby, or is it going to have to be broken up? If it's going to be broken up, Bazel's goal is to run in a very short window, a very short period of time, and maximize the actual usage. So how do you organize that? Do you do pure ephemeral builds, and do you just work on the VMware 5-minute issue? Do you do a different blend? Do you decide I'm going to use 40% of my cluster for Bazel builds and then 50% for other builds or other Bazel type builds? These are all decisions you should have organized and talked about with your company. This equipment is shared by everyone, so you got to make sure all the teams and all the organizations are on board, and that this build cycle is going to work nicely with your existing solutions, because all of this is logic and infrastructure as code. And you've got to constantly make sure the organizational value and the organizational goals are met along with the individual developers' needs and timelines. So this becomes a pretty big talking point. It's not a big deal if you address it early and you have a decent plan. And then now a quick review. Once again, the gotchas are using headers, which is easy. Dev culture, I can't de-emphasize enough. Developers just want to get things done. They want to build a great product. They want to do their job. They want to do a really good job in a fast fashion. And they don't want to spend a lot of time messing with things that don't yield fruit and don't have great results. So you just got to make sure you work with the dev culture at your company. Bare metal restore times are an issue. You just got to watch that. Decisions, custom versus general rules versus combinations. What packages do you care the most about? Which rules do you really need to write yourself? And then you got to have someone to own that. Tulsi versus XC, Hammer versus in-house, Bazel to Xcode integration. That's one of those that you got to figure out for yourself, unfortunately. And there's some great advice and opinions out there. Best practices are always going to be using single images for virtualized environment, relying on shell scripts for Bazel, and then using frameworks in Xcode. And once again, the references are going to be available in a blog post after this presentation, and I hope the bit.ly links were simple enough that you could make notes of things you wanted to go look at right after this talk. Well, thanks everyone for your attention. I think it's time for the question phase.
Yep, it's time for questions. So if you want to, continue to put your questions in the question pane, and we'll go ahead and get started answering a couple of these. So John, can you give an example of a path error and how to resolve?
Probably not how to resolve it right off the cuff, no. But one of the errors I was just looking at a little bit ago was a symbolic link error. And what happens is Bazel has a lot of logic to prevent going off the rails, to prevent circular loops. There's a couple bad architectures that are identified that'll create problems. And the value they use for logic is called maybe throw bad. So there's an evaluation criteria, and you got to read the code and actually look at the evaluation criteria for the symbolic links to not get thrown out as invalid.
Great. So our next question is, are those working on the Bazel project looking at improving remote execution, i.e. making adoption easier?
Yes, they are. Right now, there is a remote execution API. It is a constant thing that's being worked on by the Bazel team, and they are trying to make it easier moving forward. So in the next couple of years here, you can look forward to a much lower curve of adoption. That's not here yet, and that's not on, no one's talking about it being easy anytime in the foreseeable future.
Great. We have one more question. What is a sign that you've added a dependency likely to create problems?
If you need to change something, if you need to change a header line in your framework or your Bazel workspace file, you've now got a dependency that you didn't plan on that's creating problems. Then the question is, do you need it? Can you get by with trimming it out? Can you have a little custom rule? Can you have a little package that actually takes a logical snippet out of that larger dependency? And if you don't do those things and you just keep adding every time you get prompted to add, you're going to end up with every dependency under the sun, and that's really bad. So if you get prompted to add a dependency, that's when you got a problem child.
And I have one last question. What is the performance difference you've seen with remote execution versus remote caching on MacStadium?
I don't have a whole lot of experience directly with that. Our customers report back voluntarily, but the general rule of thumb is you're going to see about a 5x. So you're going to see about a 5x improvement with remote caching and 10x with remote execution.
Great. And that was all the questions that we had. So thank you all for joining us today. The video of this webinar will be available in the next few days. To stay up to date on our webinars and the MacStadium blog, please join us on our MacStadium community Slack and follow us on LinkedIn, Twitter, and Facebook. Thanks, everybody, and we'll see you next time.